Hi, everyone. Thank you so much for joining. My name is Anurag. I'm a senior product manager at MongoDB on the Atlas clusters team. We'll be talking about building performant AI applications on MongoDB, and I'm joined by my colleague, Zhao Chen, who's also on the product team. So in today's talk, we'll talk about how you can build a small-scale application on MongoDB, grow it into a larger-scale application, focus on auto-scaling, as well as talk about how you can optimize database performance. So with that, let's get started. Now, for the purposes of the next 20 minutes, let's assume that Xiaozhen and I are independent developers who love drinking coffee. In addition to liking coffee, we also love buying merchandise from coffee shops. So we have a business idea. Why don't we build an application that allows our favorite coffee shop to sell merchandise to the rest of the world? Now, because this is a hobby project, I have a few key requirements for the database that I'm going to be using. The first is I want this database to be free or cheap to use, because I don't know what the potential losses of the project are going to be. The second is I want this database to be provisioned in seconds, and that's so that I can get started ASAP. The third is I want a flexible schema, and that's because if the business requirements change in the future, I want the database to be able to adapt to it. And the fourth is I want this database to be scalable so that when my application grows, my database grows with it. As you will see, MongoDB Atlas is all of the above and more. So because we live in the age of AI coding, I'm going to use a tool like Cursor or Lovable to build the front end of my application. Here's the prompt that I used. Build a React Native plus Expo app called MerchMart, an application where coffee shops can sell merchandise. I have a few more details. And within 5 minutes, I had this beautiful front end ready. The front end had listings with images, a description, a title, as well as a price. Now, not only are these AI coding tools great at designing front end, they also make it easy for you to connect to back-end data platforms like MongoDB. When I told Lovable to help me connect to my MongoDB Atlas cluster using a Node.js driver, it created a file with a dummy connection string, and all I had to do was replace that connection string with my real connection string, and my application was good to go. Next, I was ready to move the application to production. But I did not want to move it using a MongoDB Atlas free tier, because the free tier comes with certain limitations, such as being throttled at 100 operations per second and being able to store 500 megabytes of data. I wanted a cluster tier that had fewer limitations and was ideally pay-as-you-go, so that I could pay more for the database as my application usage increased. MongoDB has a cluster tier that helps address this exact need, and that's called the Flex tier. The Flex tier comes with 5 GB of disk storage and is throttled at 500 operations per second. Not only that, it has a pay-as-you-go pricing model with a base of $8 a month and a cap of $30 a month. Unlike other serverless offerings, the Flex tier is capped at $30 a month so that you never encounter runaway bills. Now, in order to move the application from a free tier to a Flex tier, all I had to do was go into the UI, click on the Flex tier, and in a couple of minutes, my data was moved to a Flex cluster. So let's fast forward a few weeks. My application has been in production, the application is doing well, and other coffee shops hear about my application, and they're interested in selling their merchandise through my app. So as you can see, my business requirements changed from being an application that sells merchandise for a single coffee shop to being an application that sells merchandise for multiple coffee shops. In order to accommodate this change in business requirement, all I have to do is go to my product schema and add an additional field called shop, which would represent the store that the merchandise belongs to. After accommodating for that field in the UI and populating that field for all of the listings, my application is now ready to serve the needs of multiple coffee shops. If a requirement like this were to have come up while using a relational database, I would have had to alter the table, create a new table, or create foreign keys. As you can see, there's friction between business requirements changing and how you operate your database when using a relational database, and such frictions are greatly minimized while using MongoDB. Next, once I've onboarded merchandise from multiple coffee shops, a few more weeks go by, and I'm starting to hit up against the limits of the flex cluster. I now decide to scale up to a dedicated cluster. A dedicated cluster is different from a flex and a free tier in 3 key ways. The first is the ability to tweak your availability. And what that means is you can add additional nodes to different regions across the 3 major cloud providers. Number 2, it comes with world-class security and compliance features, such as bring your own key encryption, the ability to edit backup configurations, and private networking. Number 3, your performance is also tweakable as you can configure a cluster with memory, CPU, and storage of your choice. In order to move my flex cluster to a dedicated cluster, just like before, I can go into the UI and select and configure the flex cluster according to my needs. Or I can use MongoDB Atlas's many infrastructure as a code tools such as the Kubernetes operator, Terraform, or the admin API to do the same. Here I have code snippets of how you can convert your flex cluster to a dedicated cluster using the admin API or using Terraform. Now, in order to continue scaling, I'm going to rely on MongoDB Atlas's autoscaling feature. When I use autoscaling, I can hand over the keys of database provisioning and sizing to MongoDB so that I, as a developer, can focus on building the application and growing my users. Now, let's take the example of me where I don't have autoscaling enabled, and I have my dedicated cluster ready, and I stop paying attention to my infrastructure for a couple of days. During the same period of time, an article that has a great review about my application goes viral, because of which there's a spike in traffic. Thus, my database resources are overwhelmed, and customers on my web app now start noticing a significant latency, which leads to a poor customer experience. If I did have autoscaling enabled, what would have happened is that the autoscaler would have noticed that the cluster resources are starting to get overwhelmed, and it would have automatically started scaling me up to a bigger cluster tier, ensuring that my workload always has access to the right resources to ensure the lowest amount of latency for my customers. Now, under the hood, the Atlas autoscaling feature has 2 separate features that work in tandem to deliver a great product experience. The first is reactive autoscaling, in which the way it works is that the autoscaler has certain thresholds, and if your cluster resources exceed those thresholds for a certain period of time, we scale you up to a higher tier. We also have predictive autoscaling, which looks at historical workload patterns, and if we notice repetitive patterns, we scale you up before your workload spikes so that your cluster has access to the right amount of resources at every single point of time. Atlas autoscaling also helps scale the cluster down. So let's say your workload spike dies for a certain period of time. We'll scale you down to a lower tier, thus ensuring that your workload always gets the best price performance. With that, let's talk about how we can optimize database performance.
Thank you, Anurag. Hello, everyone. My name is Xiao Chen. I'm a product director of the MongoDB core database team. So my favorite part of being the last speaker of the last session of the day is that I'll be the person announcing the drinks available. But for the next 10 minutes, I will tell you how can you use the features and automations we have in Atlas to optimize your database performance. So just following the story Anurag was telling, that now you have a production database. You want to keep optimizing the performance of your queries and your database to make sure you gain the most from what you're paying for. So optimizing performance in the past is a very complicated task. It usually requires very deep and specialized database knowledge and also a lot of time. So fortunately, in Atlas, we build a lot of features, tools, and automations to make this easier for developers who's not super familiar with database to do these things. So in the limited time we have today, we're going to talk about 4 different topics. We'll start with how do you monitor the database performance and find the bottleneck of slow running queries. And then share some tips about when do you create indexes and optimize your database schema. And then we are also going to talk 2 performance tips specifically to vector search, which is quantization and also use of search nodes. So all the performance tuning started with knowing your system and identify where the bottleneck is. So in Atlas, we have this one-stop experience to help you to know everything about your database performance in the Atlas portal. So you can monitor your database resource usage, including CPU, memory, network, I/O, in the Atlas portal. And moreover, you can use this new query insights page to see your query performance at different aggregation level. So you can see, like for a certain collection, how many queries are running, how much time those queries are taking, and then you can dig into individual slow queries to see how many times that query is running, how many documents that query is scanning, and how long the latency this query is, and also if this query is using an index or if this query is doing collection scans. So all this information will help you to identify why your database is running slower or why your query is running slower, and also find a way to fix it. So before I move forward, let me ask this group a question. How many of you think you know how database index works? Please raise your hand if you know how index works. All right, keep your hands up. How many of you think you are an expert? So you always know when to create index, how to create indexes. OK, great. I see 3, 4 people here. So not everyone is an expert, database expert. And as a developer, you probably don't want to be a database expert. So creating index is a very complicated task. And another exciting feature we have Atlas is this performance advisor, which can help you to analyze your data, analyze your query, and give you recommendations about when to create indexes, what query index to create, and also when to drop those indexes you never use. So if you click into this index recommendation, on the left side, you will see like a suggestion to create an index which can help your query run faster. It's not only about like creating the index, just trust us. It's also like why you should create this index, what query shape will benefit from this index, and how much query execution time you can save from using this index. And we all know that creating index will make our read query run faster, but index will also make your write query run slower because every time when you update your data, you need to update the index too. So if you have a lot of index you're not using, it's actually not good for your database performance. So in the index advisor, we also monitor all the index usage and let you know that you never use this index, you should probably consider to drop this index. Another thing we want to talk about here is about quantization. So you probably know that to do a vector search query, you need to load all the vectors into memory to be able to run the KNN algorithm. So for a certain Atlas instance size, or if you're running on-prem for a certain machine, the size of the memory is fixed, it's limited, which means the bigger a single vector is, the less number of vectors you can load into memories. So the quantization is actually like a process to shrink the size of individual vectors, so it reduces the amount of the memory requirement for the individual vectors, which means you can either load more vectors into memory, or you can have more dimensions, higher dimensions for a single vectors. So this allows you to store more vectors or load more vectors into memories and reduce the resource consumptions and improve your query performance. So this is like mostly a trade-off between the performance and also the accuracy. So in Atlas vector search, we support 2 types of quantization. The scalar quantization, which is will shrink your full-scale vector into a less precise scalar vector, and a binary quantization, which will shrink your vector into a binary vector. So on this slide, you will see some performance data we got. So you can see with scalar quantization, you can reduce the memory footprint by 75%. And if you use binary quantization, it will reduce your memory footprint by 96%. That's a huge improvement. But at the same time, you almost get the same accuracy. Like for scalar quantization, you can retain 99% accuracy compared to your full vector. And for the binary quantization, you can retain 95% of the accuracy. And for both of the approach, you can gain more than 100% performance for your vector search query. And now, we'll have a full running vector search application in Atlas. So the good thing about vector search and search capability in Atlas is that it's a built-in feature, which means you don't have to provision additional compute resource to start. So this built-in and also shared, this shared model is very good for you to start to test and develop your applications without paying extra cost. But if you are already running like a full production workload using vector search and loading a large number of vectors into memory and query them, you probably want to have dedicated resources for your vector search queries. So that is the time you should consider to use a search node, which give you a dedicated resource and separate that from your regular database queries. So you can control how much resource you want to allocate to your database queries and how much resource you want to allocate to your vector search queries. And more than that, you can also scale them independently. So if you have more requests, you have more vectors, you can just scale up your search node and keep your database node at the same size. The last but not the least, I want to present some of the performance improvements we have made in MongoDB 8.0 by showing you some data from the industry standard benchmarks. So first is the YCSB benchmark, which is the industry standard key value benchmarks. So we made the read-only YCSB queries 36% faster compared to the previous version of MongoDB. And other read updates, which is the mixed workload with read operations and update operations, 32% faster. And for bulk inserts, which is the fastest way to load your data into MongoDB, in MongoDB 8.0, it is 56% faster compared to the previous versions, which means you can load more data into MongoDB in shorter time. And for time series, thanks to the block processing technology we introduced in MongoDB, which will process your data in blocks instead of individual documents, it improves a lot of aggregation queries, like group queries, sort queries, performance by 200%. It's a very impressive improvements. So if you haven't using MongoDB 8.0 yet, I will highly recommend you to consider to upgrade, to plan and consider to upgrade your database to 8.0 so you can get benefit from all these performance improvements. So this will wrap up our today's session and also today's events. Like I said, there are drinks waiting for you guys outside. So thank you again to come to our session. Thank you again to come to the .local event. And please go out, grab drink, mingle with others, and enjoy the rest of your day. Thank you.